Okay, class, we're going to review constant of proportionality and rate of change today. So remember, we can abbreviate those since they're kind of long. So when you see ROC, that means rate of change. And remember, rate of change is the change in the y values divided by the change in the x values. And then COP we are using to stand for constant of proportionality. And constant of proportionality is, remember, where we just divide y by x. One y value divided by one x value. And remember, we can only do that if it's a proportional relationship. So we'll review what that means in just a second. But both of these mean unit rate. So remember, if you find the rate of change or if you find the constant of proportionality, either one, you have found the unit rate, the amount for one item. So let's look at some examples from words first. Our first example says Matt pays $35 per month for his gym membership. So we're looking for a unit rate. I see one right here. It tells me he pays $35 per month. That's already $35 for 1 month. So I know 35 is my unit rate or my rate of change. So the rate of change here is 35. In our second example, it says Mark should say Mark already has $20 and will earn $8 per hour working. So this time we're given two amounts, but again for our rate of change, remember we're looking for the unit rate, the amount for one. So it says he has $20. Well, that's just the amount that he's starting with, but he's going to earn $8 per hour. That gives me my unit rate. That's how much he's going to earn for 1 hour for each hour every time he works for an hour. So here our rate of change is 8. So let's talk about proportional and non-proportional again for a second. In our first example, the only thing Matt is paying for is the $35 per month membership. He's not paying any other fee or anything like that. So in this example, we have a proportional relationship because the only amount involved is the unit rate, the rate of change. So we could also say, since this is a proportional relationship, we do have a constant of proportionality, and that is also 35. So just remember, if it's proportional, your constant of proportionality is going to be the exact same as the rate of change. So if you found the rate of change, you've also found the constant of proportionality. In our second example, though, it says Mark's going to earn $8 per hour, but he already has $20. So in this one, we have more than just the unit rate involved. We have a starting amount or an extra amount right here. That makes this not proportional. Which means we have a rate of change, we just don't have a constant of proportionality. So there's no COP. Okay? All right, so now let's look at some tables. So if you're given a table to determine the rate of change, remember we want to find that change in y and divide it by the change in x. So we've got to find the differences. Remember, when you're looking at a table like this, x is going to be on the left, y is going to be on the right. So I'm just going to start by finding my differences. On the left side of my table, my x values from 2 hours to 4 hours are increasing by 2. And then from 80 to 160 miles is increasing by 80 miles. So this is my change in my y values. This is my change in my x values. So now to find my constant rate, my rate of change, I want to know just how many miles they go per hour. So now I just need to divide. The total amount of miles, 80 that they went over the course of 2 hours divided by 2, and I get 40 miles per hour. So that is my rate of change. Now, we know we have a rate of change. It's 40 miles per hour. We also want to check to see if we have a constant of proportionality. So remember, if it's proportional, there should only be one amount involved. It should just be the rate of change. So if I'm looking at this table and I want to see if it's proportional, I need to figure out if I just divide y by x every time, do I get the same number? So if I divide 80 by 2, I get 40. And then if I try another one, 160 times divided by 4, I get 40. So in this table, when I take my unit rate of 40 miles per hour and I just multiply it by the x value, it gives me my y value. All I have to do is multiply it by the unit rate. That means this is proportional. I don't have to add any extra amount or any starting amount. So this is proportional. Label that at the top. So you know that means that my rate of change is also my constant of proportionality. So my rate of change and my constant of proportionality are 40 miles per hour. Okay, now let's look at the second table. So in this one we just have x and y. Again, we want to start by finding our rate of change. So from 10 to 40, we increase by 30. From 0 to 20, we increase by 20. So remember, change in y divided by change in x. So I'm going to divide 30 by 20 to get my rate of change. Now I can just simplify this fraction. I can say, I could cancel out these zeros because 10 divided by 10 is 1. And so I can just simplify this to my rate of change as 3/2. So if I wanted to check if this table is proportional or not to see if there's also a constant of proportionality, if I take my rate of change and I multiply it by my x value here, 0 times 3/2. Remember, you can type that into your calculator with the fraction with parentheses. So I can just type in 0, parentheses, and then to write 3/2, 3 divided by 2, and then just press enter. That gives me 0. But if I look at my y value, I know I need to get to 10. So after I multiplied by my rate of change, I'm at 0. What else do I have to do to get to my y value of 10? Well, I would need to add 10 to 0. So I have to add 10 more. If I look at that with my second x value, so if I try 20 times my rate of change, 3/2. 20 times 3 divided by 2, I get 30, but I need to get 40. What else do I have to do to 30 to get 40? I have to add 10. So see how we started our table with 0, 10? That's our starting amount. That number, the y value that's with the x value as 0, tells us what our starting or our initial amount is going to be. So I know that 10 is going to be the extra amount that I have to add. So just remember the difference. Proportional means all we're doing is multiplying by the unit rate. Non-proportional means I'm multiplying by my unit rate, my rate of change, just like over here, but I also have to do something else to get to my desired value. I have to add something, maybe subtract something. So that's what makes this not proportional, which means there is no constant of proportionality. Okay? Now on the back of your page, find the example from graphs. Okay. So remember, from graphs, we can always pick points and make tables from there. So this is going to be really similar to what we just did with the tables. One thing you can go ahead and do, though, from looking at the graph is determine if it's proportional or not. So this graph on the left is proportional because it starts at 0, 0. My line crosses the y-axis at 0. That just tells me there is no starting amount. There's no extra value that I'm going to have to add or subtract. This one is non-proportional because the line is crossing the y-axis at a different number from 0. It's starting at 3. So I know whatever unit rate I get, I'm going to have to still add 3 extra to get to my y value. Okay, so let's pick some points and make a table. Remember, we only need 2 points to find the rate of change. So on my proportional graph on the left, I'm going to choose this point right here, 324, and I don't really see another great one, so remember we can always use 0, 0. So I'm going to use 0, 0, and then 324. Okay, so now remember, find our rate of change. 0 to 24, I'm adding 24. 0 to 3, I'm adding 3. And then I just need to divide. 24 by 3 is 8. So since this is a proportional graph, remember 8 represents the constant of proportionality and the rate of change. So in terms of what our graph is telling us, that amount tells us that they traveled 8 miles per hour. Okay, now on this graph, again, we just need 2 points. I'm going to choose the one I started with, which is 0, 3. And then I'm also going to use the one that it already gave me right here, 4, 6. Okay, so here I'm adding 3 to my y value, and I'm adding 4 to my x value. So to get my rate of change, 3 divided by 4. I can leave that as a fraction, 3/4, or we can turn it into a decimal, 0.75. Now remember, since this one is not proportional, we don't have a constant of proportionality. We just have our rate of change. So 0.75 is just the rate of change. And our starting amount, our initial value, is 3. Okay, so let's see what that looks like in an equation. When you're given an equation, it's actually really easy to identify the rate of change because the rate of change is always going to be the amount that's being multiplied by your variable x. So right here, x is being multiplied by 4, so I know my rate of change is 4. That's what's happening every time. We could say this is $4 per hour, and x just represents the number of hours, so our rate of change is 4. This is also a proportional equation because all I see involved is multiplying my unit rate, my rate of change, by x. I'm not adding or subtracting anything extra over here. This is all I'm doing to my x value to get y, is just multiplying it. So if this is proportional, that means I have a constant of proportionality. And remember, it's just always the same as our rate of change, so it's also 4. In the second equation, this one is obviously non-proportional because we are adding that extra 6 at the end. So I can see in my equation, I'm starting by multiplying my x value by 3/4, but then to get my y value, I also have to add 6. So I'm not just multiplying like I was over here, I'm also adding something extra. This is my starting amount, or my initial value. That would be if I'm looking at the graph. My graph for this equation would start at 6.